your phone or your computer microphone is muted. We do want the session to be interactive, so please use the chat feature or the Q&A feature to ask any questions or anything. That'll appear in the Microsoft Teams window on the icon on the top, and you can type in your question on the right-hand side after you click that. And I will, Tim, I'll try to include the questions with respect to the slides as you're going through. But feel free to ask anything either during the session or at the conclusion of the content. We'd certainly appreciate that. As I mentioned, we are recording the webinar, and it will be available in a day or so on the AMETEK Process Instruments YouTube page, and that link will be posted in the chat window as well. And just finally, AMETEK Process Instruments is sponsoring this webinar. We are a worldwide manufacturer of a variety of process analyzers and instrumentation, and serve a wide variety of markets, not only the combustion space that we're going to talk about today, but hydrocarbon processing and refining and natural gas and power gen and others. So all of our manufacturing and manufacturing facilities are in North America, and we have direct sales and service offices around the world, supported by a global network of representatives and distributors that support our users locally in almost every geography around the world. So with that, I'll turn the presentation over to Tim and Joe.
Thank you. Good morning, good afternoon, good evening. Thank you for joining us today. As John mentioned, my name is Tim Tallon. I'm the Combustion Product Manager here at AMETEK Process Instruments, and I'm here with Joe Lebarty.
Hello. I do technical sales support, which involves quotes and processing orders. And I've quoted for quite a few of these remote mounts already. So I'm here to support Tim.
Yeah, I appreciate your help, Joe. So as we dive in, we're going to talk about considerations for remote mounting flue gas analyzers. So to do that, we'll provide an overview of the critical elements that I tend to think about when it comes to remote mounting a flue gas analyzer for successful installation. And so we'll talk about some of those most common drivers for remote mounting. So when does it make sense to remote mount? What are the technical configurations that we think about here at AMETEK Process Instruments when it comes to remote mounting? What are the elements in the configuration and in the package itself that are important to talk about? What are the ramifications? What are the implications after the fact? Anything to think about? And then also, what are alternatives to remote mounting? If in the case that you wanted to continue to mount to the process flange. I'll also be watching the chat, but John, at any point, if you think it makes sense to interject, feel free to put in a question. I'm happy to answer along the way. We'll also have time at the end to answer the questions. So just getting started, before we go into remote mounting, let's talk first about what is the ideal installation. So from our point of view, the ideal installation is actually close coupled. So that's a term that we use around here. And what is close coupled? Well, a close coupled configuration is when the flue gas analyzer is directly mounted to the process flange, to the heater flange. So in this case, you can see we have a flue gas analyzer here mounted directly to the process flange right next to the heater. And the reason why we recommend this way is because it has the advantages of having the fastest response time. There's no additional lengths, there's no additional disruptions between the process and the flue gas analyzer. Beyond that, there's less potential for cold spots, because the only place for a cold spot would be at the process flange, and if the heater's hot and or you insulate the flange, you reduce that risk of cold spots significantly. There's also the fact that there's no additional electrical demands. There's no other power other than the power to the analyzer itself. As you can see here, it's pretty simple. So it's not very complex. It's a pretty simple installation. So then you might be wondering, well, why remote mount then if there's all these advantages? So there's a couple things that I'd like to share. So why remote mount? Well, while close coupled is ideal, sometimes it's not always practical. And so over the last many years, I've noticed that practicality is a very important consideration. Some things that also come to mind are safety and then also convenience. So when we think about practicality, it really comes down to where's the nozzle? And I know I was talking with Joe, and Joe kind of joked about it, but it really comes down to location, location, location. So I don't really want to talk about that, Joe, at all.
Yeah, that's a term commonly used for real estate, but it's very appropriate for this discussion too.
So it really depends. As we think about practicality, you got to think about the location and what, is it too difficult to access? Is it at the grade level? Is it too hot? Is it too high? Is there too much vibration at that location? So let's look at some examples. So some examples that come to mind would be like an example where you have the grading right here, and the process flanges and the heater flange is right underneath it. But then on the next platform underneath, it's too high to access. In this case, the nozzle might be too difficult to access. We might recommend remote mounting in this case. Another example would be if the nozzle is too close to the grating. I've heard a number of stories where technicians, distributors, sales representatives, they've all had to, in different instances, like almost work on their bellies in order to work on their stomach in order to maintain an analyzer that's mounted at the grating level. You can still make the installation, but it's also might be very difficult and might be very, from a practicality standpoint, difficult to maintain when it's too close to grading. Now, I've seen a number of things with too close to grading. Sometimes it's below the grading, and I've also seen instances where it's underneath the grading and you have this little removable compartment to actually access it. So there's a lot of different things that customers have done to mount it to the process flange, but it may just be easier to remote mount. So other examples would be if the nozzle is too high. I mean, sometimes the nozzle is out of reach of a platform. Okay, so that's something to think about. And then, in this case, what if the nozzle was up here or over here? You'd want to be ready and able to access the nozzle in order to maintain the probe, but you'd also want to be able to access it. How do you access that more quickly? To maintain the analyzer, you could remote mount it. Other examples would be like if the nozzle's too hot. If it's too hot, you don't want the electronics to burn up. You could put it a couple feet away or a few feet away in order to maintain the analyzer electronic integrity from the high temperature.
Hey, Tim. It's also a safety concern. Sometimes the area is too hot for a technician to comfortably work in that area, and so the remote mount option provides a level of safety in that respect too.
That's a good point. I've also heard examples of where people's boots could burn up or start to melt because it was so hot in that area. So yeah, that's a good point, Joe. Between practicality of the electronics of the analyzer and also safety, it's definitely something to think about at certain locations. And this is just another example of just too hot. So just being aware of what is the local temperature, the skin temperature of the process. So those are some points about practicality. What about safety then? I mean, a lot of the practical points also relate to safety, but what are other safety considerations? Well, something that I've noticed is that, when the location of the nozzle is not in a safe or readily accessible location, and also if you were to want to reduce personnel time in a hazardous area. So to give you an example, like say the nozzle is up way, way, way high, it might be a lot more straightforward just to install it on the process flange. It may be better to just remote mount it than to install it on the process flange and have a lift every time you need to access it, or a permit to climb in order to access the analyzer. We want to be safely minded. Remote mounting can be a safety minded choice. Beyond that, also I've talked to customers, and there's also the idea of reducing personnel time in a hazardous area. If there's a risk, or even a minor risk of exposure to something in a hazardous area, it may make more sense than instead of having it on the height of the reactor of the vessel or the heater or the reformer, to have it maybe outside the zone or outside the area classification, so that it's brought to grading where it's a safer location, easier to access, and it reduces personnel time in a hazardous area. And then The last thing that I've observed is just really convenience. We kind of take that for granted, but convenience can really be important when it comes to maintaining the analyzer and also reducing additional cost and scope for projects. To give you the first example, you could install a flue gas analyzer way up on the stack, but it may be more practical and more easy to access and to maintain if it's brought to the ground level where it's easier to access. So for convenience sake, it makes it easier to maintain with a remote mounted system. And then when it comes to reducing costs and effort, sometimes you have to think about, like, if you're going to add a platform, there's a cost associated with the platform. There's the expense. There's also the cost of shutdown to install. So all those costs add up to create a much bigger project than simply remote mounting it to a process heater. So for all of these things I've observed, it really comes down to remote mounting becomes a solution for practicality, safety, and convenience. I don't know, Joe, if there's anything you wanted to add to that.
In the examples that Tim just showed, by remote mounting and locating the actual analyzer into an area where it can be accessed easier by a technician, the only active components is basically the probe up top. So our systems and our probes require very little maintenance. And so it's most of the maintenance and checking of the analyzer can be done a lot easier in that respect.
Yeah, that's a good point. All right, so now these are some of the practical reasons for remote mounting. Now let's talk about some of the configurations. So just from my point of view, there's really two general configurations. Like the first one would be just being mindful of the location of the nozzle. Going back to location. So is the location of the nozzle above the sensor or is it below the sensor? Now, it may seem like a funny question, but it actually has some implication into how the system, the remote mounted system, is designed. For example, if the nozzle is above the sensor, we'd be more inclined to have the boot at the back of the sensor attachment to go right straight out, so the heat sample line could have the most flush and least amount of curves before getting to the process flange. Okay, well, that's one thing. What if it's below? Well, if it's below, we'd be more inclined to having the boot at the bottom of the sensor attachment, so it has less curves, an easier path in order to reach the process flange. So from a configuration standpoint, being mindful of whether or not the sensor is going to be, the nozzles above or below the sensor plays into the design. Now, one other thing that we think about is also the length of the heated sample line. Now, we'll talk about this a little bit more later on, but just something to be mindful of is, okay, well, there are really two different types of heated sample line configurations. There's short, which we call short coupled, and then there's also long distance. Where's the breakoff point? There's generally like less than 15 feet or 5 meters is the rough cutoff point between short coupled and long distance, but there's no real rule of thumb on that. But to give you an example of a short coupled system, this is a unit that I saw in the field where, if you notice the process flange is actually not accessible to be close coupled. There's some obstructions to the left and to the right, and in order to make this a successful installation with minimal impact on response time, there was a little bit of a heated sample line to get it to the platform before it's maintained and monitored. So this would be an example of short coupled, in this case, less than a half a meter, less than a foot and a half or so, just to access. So this is one example of short coupled. What other examples are there? Well, this is another example where, if you notice, the heater flange is actually not in a very accessible location. Well, what was done instead was, instead of having the analyzer directly mounted to the process flange, it was short coupled with a couple feet of heated sample line onto the platform for easier service and maintainability. Now, when it comes to longer distance remote mounting, that's where anything above 15 feet or so, 5 meters, tends to have a little bit more complexity. So we got to be more mindful of how are we going to pull the sample? Are we going to use an inductor? What's going to be the motive force? So from an overview of configuration standpoints, these are the two configurations that we think about, and then also playing into the lengths. Anything you want to comment on, Joe?
No, I think you covered that area.
Okay. Right. So then as far as notable elements, I know I've showed you a number of these pictures before, but what are some of the elements? So let's talk about each of them separately. So you can see here there's a number of moving parts. Let's talk about them individually because they all play into the remote mounted system. So we also have this one. So let's talk about it. So if we go back to this example with the short coupled, you'll notice that there's a number of pieces to it. There's this attachment up here. There's this box here. There's the flange. So what do we see? So in this case, I see that there's a rack in which the analyzer is mounted onto. There's the sensor attachment. There's the power termination kit. There's the end termination kit for the heated sample line. And then there's the remote probe flange in this case.
Hey, Tim, I'd like to point out that this example shows the boot out the bottom. So I just wanted to just kind of illustrate that. Sometimes we have it out the back, as Tim showed earlier, but this one is a good example of how we can have the boot out the bottom and keep the heated sample line as short as possible.
Yeah, that's a good point, Joe. If this was the boot was straight out of the back, you'd have an additional curve, and that'd be a potential point where you're adding length that's not necessary, and also you're adding additional curvature that you don't necessarily need in the system. Yeah, thank you for that. Good point. So as we
Tim,
look at,
there was one question on the heated sample line. Just said when using a remote mount, what size tubing in the heated sample line is used between the sample point and the analyzer? Is it 2 tubes? So I don't know if you guys are going to discuss a little bit on the heated sample line, but there's a question around that.
Yeah, well, we can talk about this later, but we can answer right now. So the quick answer is we recommend 3/8 inch tubing. I don't know if you want to comment on that at all, Joe, but aside from the 3/8 inch tubing, we like to have 2 tubes available for 2 reasons. One, because it's a return to process system. So if you wanted to return the sample back to the process, 2 tubes would allow you to always return it back to process. And then also, if you did not want to return it back to process, you would at least have a spare. If you wanted to vent it to atmosphere, you would at least have a spare that would always be available should the first one be plugged.
Right. As Tim points out, a lot of customers, if it's short coupled, they prefer to have the sample returning to the process. In that case, the second tube is for returning to the process. For longer runs, customers often decide to vent it to atmosphere after the location of the analyzer. And in that case, you have a spare in case there's anything that goes wrong, or if you need to switch over to the second tube to flush out the first one.
Yeah, thanks for that point, Jeff. Great question. Great question. We'll talk about a little bit more about that later, but certainly happy to answer that, and we'll highlight that when we get to it later on too. So just going back to these elements. So we're going to talk about these individually, but you'll see that there's a sensor attachment, there's the heated sample line, there's what we consider our standard versus a custom option. There's a controller that you can't really see here for the heated sample line, but that's important. There's the power termination kit, the end termination kit. There's an aspirator in here that we'll talk about. And then there's also different mounting attachments. So we're going to go into each of these, but just as a quick highlight, these are some of the typical elements in a remote mounted package. So if we look at this specific configuration, let's talk about the sensor attachment first and go one by one on those different elements. So if we look at the sensor attachment, the advantage of having a sensor attachment is to have the reduce potential for cold spots. These sensor attachments are insulated so that as soon as you get from the heated sample line, you have a space where it's going to be maintained at a temperature. You could use the heat trace to even wrap around some of the tubing before you get to connect to the analyzer. So it maintains the temperature of the sample. It reduces cold spots from rain that may dramatically reduce the temperature of the exposed tubing between the heated sample line and the sensor. And it also provides an easier connection point so that you can just directly mount the back of the heated sample line, so it's less exposed to the elements.
Okay, I'd like to point out that we use the boots to seal up around the heated sample line, and that keeps the heated sample line from being compromised by rain or snow, and it just seals up very well. So we use them both on this end and on the probe end.
Thank you, Joe. And so if we look at some of the other pictures around that, so you'll see that this is the end of the connection for the heat sample line, like Joe said, at the end of the boot. You'll see that there's a little bit of insulation inside just to keep it warm before it connects to the back of the process. And this is sort of like what it looks like when you look from a back before you heat up, before you bring in the heat sample line. So then when you look at it from the boot at the bottom perspective, you can also see when the nozzle is below the sensor, you can also see that it connects right into the attachment, just a cutaway, and a nice, more straightforward, reduced risk of cold spots with this type of heated sample arrangement. And then for customers that wanted, if anybody were to want to upgrade from a wall-mounted system to a remote-mounted system, for any of the reasons we talked about, practicality, safety, or convenience, there are ways to do that. So just looking at conversion kits to go from a wall-mounted system to a remote-mounted system, say the temperature of the process got hotter, or say there's some vibration that was not expected, those would be ways that you could, with a conversion kit, go from a flange-mounted connection to a remote-mounted system, even short-coupled. And so one other thing to consider, if some customers also just like to have a unistrut design, that's certainly another way that we could, for a remote-mounted analyzer. In that case, you could use this straight fitting for when to bring the boot out, as we said, with the boot out the bottom, you could connect straight out, or if the nozzle was above or below, you could have the elbow to move up or down. Anything you want to comment on that, Joe?
Yeah, I just wanted to point out that this is an option that we have for our analyzer, so that the customer doesn't need to order or supply the unistrut as shown in this picture. We supply it as an option, and then all that is needed is for the customer to supply either the heated sample line or the tubing, and we can supply the analyzer.
Thank you. That's a good point. So this is just another option we've seen in the past. And it's just an option that would be easier for the remote-mounted situation that you're looking at. All right. So we talked about that was all with the sensor attachment. Now, if we look at the heated sample line, we can talk about some of the nuances with heated sample line. And I see that there's a question about the construction of the tubing. Tube material is certainly an important element of it. We'll get into that just a little bit, but certainly there's Teflon versus stainless steel. For a number of reasons, we recommend stainless steel. I'm not as familiar with the ceramic type, but I'll get to that in just a second. So if we just go into the heated sample line and think about what goes into it, well, we got to think about the ambient conditions. We got to think about the process conditions. We got to think about what's the coldest temperature could be in the area, how much you want to hedge against, the temperatures around the world. I mean, this is just one example from the United States, but you can see that depending on what state you're in, the coldest temperature recorded could be significantly different. So just something to think about there. I don't know if you want to comment on that, Joe.
Right. If we're going to design the complete system for you, we'll take it into consideration, and we'll ask you what the ambient temperature that you need to have the sample line rated at. if you're going to be taking on this as a project yourself, the lowest temperature is definitely worth thinking about, but you might want to consider, was that the world record lowest temperature, or is it more likely that that the temperature only goes down to about freezing or a little bit below freezing? So this is all just consideration that you need to take for good engineering practices.
Yeah, thank you, Joe. And some things that we think about are like, is there sulfur or hydrochloric acid or any other type of uh, compound in addition to water that would create a dew point that you need to be aware of, especially as customers start to think about hydrogen as a fuel. There's going to be a lot more water, so making sure that you're above the water dew point sufficiently. Then also just thinking about any other contaminants that may be a reason to choose one tubing material over the other. As far as hazardous area locations, you want to be mindful of local hazardous area classifications, and be thoughtful about like what's the tube material, what's the number of tubes. We proposed our approach of using 2 tubes all the time, but that's just something that we use our discretion on. Other things would be voltage as well. So all those things play into the heated sample line, and it really does change the overall end product, because you could see that there's a lot of different options. There could be a blowback line, or there could be a self-heating temperature line. There could be a calibration gas line. There's a lot of different things that can plays into the design of a heat sample configuration. It's very customizable. So if you were to do it yourself, just be mindful of how did these, what's the balance that you want to pour into it.
And Tim, there's a question in the chat on the desired temperature to maintain in the sample line.
Sure, that actually brings me well to the next slide I was going to have. So this is an example of a common heat sample line. This is something that we've worked to standardize on. So if you were to look for our standard, quote unquote, standard heated sample line, it's with this type of specification. It really becomes process specific though. Like this is not the end. This is not the only heated sample temperatures, but this is something that we aim for. So when it comes to looking at just the water dew point, we've designed our heated sample line centered around having low temperature of minus 20 degrees Fahrenheit, minus 29 degrees Celsius, all the way up to plus 104 Fahrenheit or 40 degrees C. Now that's supporting process temperatures between 126, so maintain the process temperature above. It really depends on the ambient temperature, but maintaining the sample above 126, above 256 degrees Celsius or above 124 degrees Celsius, and then on a hot day, also making sure that's above 300 degrees Fahrenheit. For what if the process is 800 degrees Celsius, even at 800 degrees Celsius, you don't have to maintain the sample temperature at 800 degrees Celsius. You have to maintain it above the sample dew point, but with the heat capacity of gas, a lot of that temperature will be reduced immediately as soon as you start to get into a few feet of the heated sample line. So even if the process temperature might be 800 degrees C, you still may be able to work with heated sample line in this way of above the acid dew points. So just something to think about, because I see some comments in the chat. And then other things, just standardizing on a design that's standardizing on a heat sample line that's rated for CSA, for Canada, for Europe, for Class 1 Div 2 for North America, keeping all those things in mind. The tube material that we use 316 with 2 3/8-inch parallel tubes that reduces the risk of plugging. We've had concerns about doing 1/4-inch parallel tubes, and for our standard design we used 120 volt, but with a 120 watt tracer. But anything you want to comment on, Joe? Because this is just our standard design, but there's a lot of thought that was put into this.
Right. We also use stainless steel typically because the process that we put our analyzers on is often very hot. And so we like to make sure that the connection to the process isn't compromised by using Teflon. And then it also helps conduct the heat for the short piece between where the process starts and where the heated sample line takes over. So that's the main reason why we use the stainless steel. And I think that Tim's next slide or close to it will start to get to, or maybe a little bit later, we talk a little more about the voltage that we use. He has just one line down here that we typically use, the 120 volt with a 20 watt tracer in it. And with a controller that allows us to get at least up to the maintained temperature of 225. We could probably go a little higher for those applications where there's a very mild acid dew point.
Yeah, good point too. And I see a comment in the chat about why does the bundle have aspirator drive tubes? So this is again our standard. All heated sample line can be customized, but we like to have the ability to have an aspirator because for lengths greater than 15 feet, 5 meters, we recommend an external aspirator. So just having in our standard design the ability to use an aspirator to provide additional suction to pull the sample through the heated sample line to the analyzer and back. So that's why there's in this particular case our standard heated sample line has aspirator drives and spare. If you were to do it yourself, that'd be a consideration that you'd have. If you don't have, if it's less than 15 feet, you could work with the aspirator of the analyzer itself. Great question. Great questions. Thank you. All right. So if we, so we talked about just the heated sample line again, considerations on heated sample line. Well, what else is there to think about? Well, let's talk about the termination kits. So there's a power termination kit that kind of acts as a junction box that supports the power. I don't know if there's anything specific you want to talk about that, Joe, as far as power termination kit.
Yeah, there's not too much to this. It just allows it to be connected safely electrically. And this is just one example. We typically use a certain type of sample line all the time, and this is their electrical termination for the power.
Yeah, thank you. And then if we were to look at just the end termination kit, this is just an example. This is one example that we use every once in a while. Anything else that you wanted to comment on about the end termination kit, Joe?
No, there's not too much to this. There's a lot of detail, and then the actual power and end termination kits. There's extra information about those if we use this kind that we can provide.
Thank you. All right, so just to, as you think about that, so when we go back to the short couple example I keep going back to, you can see the power termination kit here with on the respective rack, and then you can also see the end termination kit. Just to give you some visual examples. So just something to think about. It's just a part of the heated sample line system. Now let's talk about actually mounting to the process. And really, when I think about mounting to the process, there's actually two options that I think about. The first option would be just a flange. Just a flange, okay? A flange that's just mounted to the process. Okay, so how would you do that? So if again, we go back to this great example right here. But if you notice, of all the elements, it's actually using a remote probe flange. There's a flange here, and you can barely see it, but you can see that there's a little bit of exposed heated tubing, or heated sample line tubing, before it goes onto the process. That could be a potential cold spot. I'd be concerned about it being a cold spot. But that being said, that is one way to connect this heated sample line to the process. So when we think about those flanges, okay, you got to make sure that they're designed for the right rotational orientation. Okay, is the top hole on the top of the flange, or is the top hole straddled? Is 12 o'clock straddled by the two bolt pattern orientations? Also, something that we think about is, do you want one place to put the tubing in the probe, or do you want two for a potential spare?
Yeah, the two tubes that we have in this example, these are used for returning to the process. Some customers, once again, on the top row, they only want to pull the sample out and sometimes vent the sample to atmosphere in the back of the analyzer or near the rack.
Good point. Good point. So these are just some things to think about, especially if we're going to go down the path of working with a remote probe flange.
If we make the flange, we make sure that it can use our standard probes. So we machine it correctly to have fittings and bushings needed to just so it can be used, our standard probes, for easy maintenance and access.
Yeah, good point. That's definitely part of the convenience element of remote mounting, is being able to work with standard parts and standard probes. So that's the first option. Option one is with the flange, and then I keep alluding to this box over here, but there are advantages of having what we call a remote probe box. Okay, so it has the flange, but it also has an additional connection with the boot in it. I apologize for the busy backgrounds, but this is just a way to really efficiently show you some of the things that we have in the factory. So with the WG5 remote mounted, you can see that this is the remote probe box. You can see that it has a space for the boot itself to tie into. When you open it up, you can see it's insulated, so it'll keep the high temperature from the heated sample line into the short distance between it connects to the back of the process. The big advantage here is, again, it's a simple thing, but it reduces the potential for cold spots. And I can't reiterate that enough, because that's one of the most common things that we see as issues with a remote mounted system, is too many cold spots causing plugging because of water condensation. Well, with a simple box like this, you reduce that risk significantly, and it makes it easier for you to maintain on the process flange. So you can kind of see that here, how the process flange would be here and how the boot goes through here. Just some other example would be this, there's the flange I was talking about before. So here's the flange. You can see the flange is designed, in this case, for return to process. You can see again with the bolts, and then again, this is just another view of it before.
Hey, Tim, can you go back to that last slide?
Sure. This one?
Yeah, that's good enough. So we custom design these boxes. We sometimes call the insulated probe enclosures, and this flange that we put on the back, the one in the picture might be a 4-inch 150 or a 3-inch 300, but we've made them for several different sizes now and rotational orientations. And as you can see, it's pretty beefy. It's heavy duty. We have studs built into it so that it can be securely mounted to the process flange, and everything seals up real well. You'll see later on that this also has the ability to use our standard probes. So they can, once it's bolted onto the flange with these studs and nuts that we provide, then it's pretty easy if someone needs to ever access our probe to open up the box and disconnect a couple fittings and pull out a probe to do any maintenance.
Definitely a big advantage, Joe. Thank you. And then going to just another view that you can see now from the boot perspective. If you were to attach the boot on, this is where it couples up to, and then you can see it's easy to open up the respective remote probe box. So what it comes down to, like if you look at it just from this drawing perspective, you can see remote probe box has the end seal boot for the other side of the heated sample line. So when it's on the process flange, you reduces potential, maintain the integrity of the heated sample line, but also of reducing cold spots. The plumbing inside is also connected. In this particular case, you can see that there's an aspirator. We'll talk about the aspirator in just a moment. And then there's also, you can see two connections. This would be the remote, two connections for the return to process design. Things that you think about if you were to go this route, it doesn't come with the probe. You have to that would have to come separately, as well as an aspirator, because if it's less than 15 feet, we wouldn't offer that automatically. So there's some things that are to think about going down this path of planning for a remote mounted system. Just to highlight some of the advantages with this box, as simple as it is, it does reduce cold spots on the heater flange. It maintains the temperature with this installation. You can see right there. It also provides an Ethernet connection, as Joe was mentioning, to install a probe. Okay. So we talked about the remote probe box and the remote probe flange, those two options. Now let's talk about the aspirator. Now the aspirator could go in the remote probe box if it's run to run a process, or it can go at the back of the sensor attachment in the case that you were to vent to atmosphere. So the external aspirator is used for longer distances. Our rule of thumb is greater than 5 meters. Below 5 meters or 15 feet, the suction from the analyzer itself has been found to be sufficient to pull a sample for short distances, up to 15 feet. Beyond that, we do recommend the use of an external aspirator. Now, there are many different types of external aspirators. We generally use the stainless steel more often, but there's certainly the ability to use Teflon if desired. And then that's really what it comes down to. You know, if you're returning the process, you put this on located at the process flange. Even if you didn't have a remote probe box, you'd locate at the process flange. If you were to vent to atmosphere, you'd put it in the center attachment, just like you mentioned before.
So basically, if you're adding an external aspirator or reductor, that it's also called, it's always best to install it near the end of the sample line. And the examples that we have where it's in the probe box is for when it's being returned to the sample. That would be the end of the sample line as before it gets returned to the process.
That's a good point. I see that there's a question in the chat about, you know, what is the set point of pressure and why is the aspiration and why are the aspirator tubes not heated? I hope this answers your question, but I think so. A lot of this is with considerations designed for like an atmospheric fired heater or piece of equipment. If it becomes more pressured, there'd have to be a lot more design considerations around that. But for atmospheric, a lot of this presentation is around atmospheric installations. But why is the aspiration tube not heated? Part of that is because I don't know if there's any good reason.
Yeah, the tubes are that were shown on the outside, not heated. They're for the aspirator drive. So it's not really needed because it's for the motive force. And when the sample gets combined with it and that exits from the aspirator or the ductor, there's only a short length and it's also diluted at that point before it gets returned to the process or vented to atmosphere. So it's not really needed to have the aspirator drive lines insulated.
Thank you, Joe. There's also a question I see on positive pressure. Does this work for positive pressures above one bar gauge? Any ideas on that? I know we have a solution for high pressure, but it's just a question of.
Yeah, the little mini ductors we use, they're pretty powerful. There's different ones available. If you have a special application that is a higher or lower pressure, then we typically install our analyzers on right at the flange. You can contact us and we'll get with our engineering team to consider any pressure issues. But there are different options available that are very powerful, and we can actually pull the sample if it's negative pressure, or we have other options if it's a positive pressure.
Thank you, Joe. And there's also one other question I think might be appropriate to ask right now, but any idea if there's if automation is available for the aspirator drive on and off control. So
We don't typically have automation available
for the aspirator drive, yeah.
for the aspirator drive, but you know, anything's possible. That would be more of an integration.
Right.
That, and we have an excellent team of engineers that can do a wide variety of integration.
Yeah, I appreciate that. So, and then there's also, okay, we'll keep going on for the next one. There's also a question on, what can be done if there's debris accumulates in the tube and becomes clogged? Any thoughts on what to do?
Well, that's, first of all, we use 3/8 inch tubing. A lot of our installations are short coupled. We haven't had much of an issue of plugging occurring by either particulate or by the sample reaching a dew point and dropping out. But if it does, that's the one reason why we have the spare line. And there's been a lot of people that have had CEM systems all around the world now, and they're used to doing some maintenance on the sample lines. And it varies according to location of how they clean it. Some people clean it with a variety of things like distilled water, even isopropyl alcohol or other chemicals. But that would be up to the site to decide what they want to use and what their concerns are. So first of all, we don't have much of an issue with plugging. Most of the time, the applications that our analyzers are installed on are fairly clean in this respect because it's burning cleaner fuels. And then as time goes on, everyone wants to burn cleaner and cleaner fuels. It's a lot of applications are burning natural gas, but some still burn refinery fuel gas. So
Yeah.
that's all there is to it.
Good point, Joe. Yeah, I appreciate that. All right, so as we keep going, so this is just the external aspirator, and as I said, used for longer distances. You can see that the motive force is through the center, the suction is from the side. I have an example that I can show you in just a moment, but you can see that, okay, the motive force is pushed through and then creates the suction on the side. Now, how does this look if you were to put it in the remote probe box? If you're putting it in a remote probe box, you would notice that from the probe, that's the end of the probe, the sample comes in. Okay, there's the aspiration pulling in the sample through the probe. That goes through the first set of tubes before it goes to the sample process. So this would actually be up here. This will go through the heated sample line to the analyzer and then back. And then if it were to return back to process, you also have from the analyzer the exhaust, so that would go through here. The aspirator air would be pulling from over here before the exhaust and the aspirator air combine to return back to process. So just an easy way to see how the two tubes work together to return the process. All right, so that's the consideration when it comes to the aspirators. Now, we talked a lot about this. Now, what are some other additional engineering considerations? And this is kind of something that I'm seeing in some of the questions right now. So other additional engineering considerations, there's 3 that I have. There could be more, but for right now, from the standpoint of engineering considerations, the first thing that comes to mind is remote mounting will impact the response time to some effect. Now, by how much really depends on the length of the heated sample line and the tube diameter. It may or may not be possible for you to increase the flow rate on the analyzer. So that aside, as you use the standard flow rate, you'll notice that with the 3/8 tubing that we propose, if you have a 50 foot or if you have 30 feet or 10 meters, the response time, add additional time to take into consideration for the heated sample line would be another 5 seconds. If we were to go to 60 feet, that would be an additional 11 seconds on top of the existing response time. And that's just because you have the entire length of heated sample line to go before you make the measurement. There are some customers that we recommend that recommend not going any higher than 17 feet. Or it really depends on your installation, your setup, what's practical, safe, and convenient for your team to maintain. But remote mounting will, to some effect, impacts response time. If you notice, less than 10 feet is less than a 2 seconds time, less than 2 seconds additional time. Is something to keep in mind that short couple may not have much of impact at all for on response time compared to like a longer run. Okay. And then another thing to keep in mind is also that remote mounting uses more power because we are heating the sample line. We're putting power to it to make sure that it's above the right temperature, the acid dew point temperature. So that changes so that changes your consideration for what are the heat tracers and what's the ambient temperature. Anything you want to highlight on that, Joe, as it affects the length that you choose?
Yeah, so since we typically use a 20-watt tracer to make sure it's above the dew point of the process, this table just shows the requirements. We've received at times questions about what breaker to use. So since we use 120 volt tracer, 20-watt tracer, and an 80-foot length of heated sample line would then require like a 20-watt or 20 amp breaker. So this table's a little bit busy, but we're trying to show you that the length impacts what breaker to use and how much power the tracer would draw.
Thank you, Joe. Okay. And then one other thing that comes to mind, what are the other engineering considerations? Well, another option would be also to remote mount with an integrated rack that has the ability to co-locate the analyzer with the analyzer next to the post display for convenience, so that it's easier to calibrate. Also, sometimes customers like to have a bolt-on integration such as this. I mean, because you can bolt it on into the actual location you're trying to install for user connection. So that makes a quicker turnaround for when you're trying to install. And then also it makes it simpler. It gives you the ability to simplify the calibration process. You can put the calibration accessories all in one place. And you can also simplify all the conduit, junction boxes, electrical switches in an all-in-one solution that meets the electrical area classification, the hazardous area classification. So that's something that we think about. It's a value to customers because it provides an all-in-one solution for easier maintainability of the analyzer.
Yeah, I wanted to point out that we do have engineers and we provide integration like this example. It'll be customized to the location and the customer. Certain customers might have different requirements than others, and it can even come down to the location, right? Each site might have its own requirements. We take all that into consideration when we're designing this. It may not look too complicated, but once you start adding everything into it and looking at the specifications from the customer, everything is considered. And this type of integration is actually more simple than some of the ones that our engineers get involved in, where they design complete shelters with several analyzers. So I'm kind of bragging on their capabilities here, and we can definitely offer a complete integrated solution too.
Yeah. And thank you, Joe, and for all the advantages that you see here. So something to think about to make it one step easier to maintain and to install. All right, so other engineering considerations. I know we talked a little about pressure. I don't have any slides on pressure, but I think that's something where it's more of a custom thing. So just let us know if you have any questions about that. Now, I also did promise, like, what are some alternatives for remote mounting? Now, if close coupled is what we recommend, and that's ideal, it has all the advantages we talked about before. fastest response time, least potential for cold spots, no additional electrical demands. It's the least complex of the installations. If you did want to, if you were confronted with some of the earlier things about the nozzle being too hot, to grade level, or some of those things, I did want to show you some creative examples of things that we've done in order to support customers at the process flange. So one example would be to remove the. So one example, if it's too hot, the electronics can be removed and remote mounted. So the electronics can be remotely installed at a cooler location. In this case, we can put in terminals in place of the electronics.
Right. What Tim's showing here, that little box at the bottom of our sensor, we typically have our electronics located there, and instead we're showing an option that we've done more than a few times already, where we can install a terminal strip and then locate the electronics a little bit further away to keep it out of the extreme heat of the process.
Yeah, thank you, Joe. Another thing would be to, if it's too hot, an alternative could be to add a Vortex Cooler. I mean, this is something that would certainly cool down the electronics, ideally below in a good operating temperature, to maintain the electronics at the right temperature and the integrity of electronics, even if the process is exceedingly hot. So that answers the hot scenario. Well, what happens if there's just a strange angle? Like, what if there's a strange angle? This is a project we did more recently where the flange was on a 60-degree angle. So we built a little attachment on the back that bolted right up to that flange. And you can see it's a little bit curved to adapt to that 60-degree angle. And a little bit of bent tube, but that's a lot less bent tubing compared to what would be in a heated sample line setup. But you can see that it would attach right to the back of the W5, and in this case of Flue, and you can easily install a probe through this little attachment here. So just something to think about. If there's a strange angle, we can be creative. I say we collectively can be creative to think about ways that we can adapt to the process. And then anything you want to add on that, Joe?
Yeah, this is just another example of some of the modifications that we can do. Instead of the standard enclosure that we have on the back of our analyzer, sometimes we do modifications like this, and we can actually design and engineer a custom one on the back for different angle mounts, or like whatever the situation might be. Although we've talked about the boot out the back and boot out the bottom, we've done ones with the boot out the side too. So just kind of want to point out that we're very flexible, and our engineers can often come up with a very useful design for you.
Yeah, thank you. That's a good point. I forgot about the boot out the side versus. Okay, and then one other thing, if the analyzer is too close to grading, but you still like to fit in replacement, we do have the W5S, S for side mount electronics. You can see that its electronics are mounted on the side. It's a new option available for installations at the grading level. Now, again, it's not ideal to be at the grading level, but it's not impossible to install in-house. So this is just something to think about, so that you can better fit in to the replacement of the conduits that you have and the installation you have. All right, so as I said, these are other ways. This is certainly one of the designs that you'll see. When it comes to other configurations, it all comes down to creativity. What other ways can we be creative to make it fit and mount it directly to the process? So we talked about a lot today, and I really appreciate your time and your questions. Some takeaways, like I said, remote mounting really comes down to practicality, safety, and convenience. When it comes to short coupled installations, that's the least impact on response time. That's still a pretty simple, maintainable setup. For longer runs, we recommend an additional external aspirator to adequately draw the sample in, about 15 feet. For response times, it really depends on everything we talked about: the length of the tubing, the size of the tubing, and the flow rate. And then, for alternative designs, really got to be creative and thoughtful as to how we can mount it directly to the process. So I do see that there are some other questions. There was one question on how does remote mounted electronics impact the SIL rating. I I'd have to check, to be honest. I mean, I don't think that it would be still certified because it's a different design than the core setup, but I could certainly check into that. Any other questions or comments you want to make, John, before we conclude, or any other questions that stand out before we conclude?
No, Tim, a good job by both you and Joe in taking the questions as they come up in the chat during the session. There are no other questions that I saw in there. I do want to thank everybody for attending today. I know we're a minute over. I hope you found the session informative, and thank both Joe and Tim for sharing all their expertise. I did just post a couple of links in the chat. One is for the products on the website, and the other one is for information on your local representative or distributor contact in your area if you'd like to get in touch. And as I mentioned at the beginning, this session was recorded and we will post it on our YouTube page in the next few days. So thank you for your time and enjoy the remainder of your day.
Thank you very much. Thank you for your help, Joe.
Okay, thank you.
Have a good, safe day.